In this video, I'd like to discuss Kolmogorov's axioms. These are used in probability theory, and then we'll solve an example problem. So the first thing I wanted to talk about are events. Events are things that make up a probability space. So here I've shown that A is a subset of the probability space, and the probability space here is defined as a set of numbers. So A is a subset of the set of numbers that you can pick from, same as B. Then we talk about phi. Phi is equal to the empty set. We can define events as disjoint if we know that the probability of A and this symbol here means and. The probability of A and B is equal to the empty set, then we know that these are disjoint. So the probability of the probability space is 1 because you're choosing from a probability space. So if you're taking the probability of that, that's always going to be equal to 1. And the probability of the empty set is going to be equal to 0. Next, we have the probability of A and B have to be non-negative. That's another axiom. Next, if we have that the probabilities are disjoint, we can say that the probability of A or, so the upside down U means or, the probability of A or B is equal to the probability of A plus the probability of B. You can kind of imagine that we're just adding these two together because they're disjoint. If that's not the case, if they're not disjoint, they're overlapping, then we compute the disjointness like the probability of A or B like this. We still grab the probability of each, so here and here, but we don't want to double count the center. So we subtract away the probability of them when they're both there together. Next, we have the idea of independence. These events are independent if and only if the probability of A multiplied by the probability of B is equal to the probability of A and B. The final axiom here is the complement. So the probability of A complement is equal to the 1 minus the probability of A. So let's go ahead and see if we could tackle this problem now. We have consider two events A and B with probabilities listed. P of A is equal to 0.7, P of B is equal to 0.6, and P of A or B is equal to 0.88. So it's asking us to find are A and B independent and then to explain why or why not. So for them to be independent, remember P of A and B has to be equal to P of A times P of B. So let's go ahead and see if we could solve for P of A and B. So one approach to do this is looking at this expression here. We see that P of A or B is equal to P of A plus B minus P of A and B. So if we move P of A and B over to the other side and subtract P of A or B, we have that P of A and B equals P of A plus P of B subtracted from P of A or B, right? So now we have 0.7 plus 0.6 minus 0.88 equals P of A and B. So let me grab my calculator real quick and we can solve that out real quick. We have 0.7 plus 0.6 minus 0.88. That's equal to 0.42. And then if we do P of A and B equals P of A times P of B, let's see if this statement is true. So 0.42, is that going to be equal to 0.7 times 0.6? That's the question. So 0.7 times 0.6 equals 0.42. So here we see that these two events are in fact independent, and that's because P of A and B equals P of A multiplied by P of B. Awesome.